All right, so here's another video on kind of reviewing things for trig. I'm not sure how much of this is review and how much of this is new, to be perfectly honest, but these are kind of things I assume that you're going to understand quickly if you haven't seen them already. So the first thing I want to talk about is something called the principal angle. It's just something that, some vocabulary that is pretty useful to have. So the first, how I'm going to explain it is, it's all angles that are in the first circle. So the trigonometric circle is something that, because it's a circle, it's like a wheel, right? It can go on forever. So if I were to ask you what the angle here is, that seems to us like it's a 45-degree angle, or pi over 4. But it's not just that. Like, one thing you could do if you wanted is say, okay, we're going to make a complete rotation around the circle and then go until this line again. So this angle here leads to the exact same point, but it's much bigger. So the green angle would in fact be a complete circle, which is 360, so until this point, and then a little bit more until the 45. So really this angle is also, it's not just 45, it is also 360 plus 45, because it leads us to the same point. I think I'm going to zoom on this so I can write something that's actually readable. Okay, so it's not just 45, it's also 360 plus 45, which would be 405 degrees, right? Or if we were to do it in radians, it would be 2 pi, because that's a complete circle, plus pi over 4, which means we would get, so 8 pi plus pi is 9 pi, so this would be 9 pi over 4. So we could do that, but also if we felt like it, which we don't, but I'm just going to show you. If we wanted, we could do a complete circle, do another complete circle, and then stop at this line, which means in this case, it would be 45 plus 360 times 2. And that would again lead you to the exact same point on the trig circle. So the point is, if I ask you for a principal angle, what I want you to find is what would be the angle in the first circle. So for example, principal angle of, I'm going to pick a random number. Let's do 525 degrees. So because it's bigger than 360, then what you would have to do is say, okay, well, the principal angle, I'm just going to write theta, is going to be 525. We're going to subtract a circle from this. So we're going to subtract a 360 and go find out what that is. So 525 minus 360 is 165 degrees. So your 165 is somewhere here. So this angle there is not just 165, it's also 525. And we could go on like this and keep adding 360 to it if we wanted to. Same thing, for example, I'm going to give you another example for radians. So example. So if I gave you 15 pi over, let's not do 15, let's do 16 pi. 16 pi over 3. Okay, so we are looking for an angle that's between 0 and 2 pi. That's obviously bigger than 2 pi, because 2 pi would be 6 pi over 3, right? So let us subtract some circles and see. So the angle is going to be, I'm not going to write the angle yet. I don't know how many circles we have in there. So we just said one circle is 6 pi over 3, right? So 2 circles, I'm just going to write 2 circles. That's a circle, not a 0. Would be 12 pi over 3. And then 3 circles would be 18 pi over 3. So I'm just adding 6 every time. Meaning that here, in this thing here, we have a little bit more than 2 circles. but not quite 3. So what I'm going to do to find my angle is I'm going to take my 16 pi over 3 and subtract 2 circles from it, which is 12 pi over 3. So 16 minus 12 is obviously 4. So this is an angle of 4 pi over 3. So 4 pi over 3, where is that? It's in this quadrant. Now it's kind of weird because none of my colors actually match, but let's pick purple. So 4 pi over 3 is going to be somewhere here, somewhere in this quadrant, meaning that this angle here is not only 4 pi over 3, but it's also equivalent to an angle of, I don't know what symbol I'm using here. I'm going to use this. It's going to be equivalent to an angle of 16 pi over 3 as well. But the principle of 16 pi over 3 is 4 pi over 3. I hope that makes sense. Okay. The other thing I want to talk to you about a little bit is the revolutions around the circle. So we're going to start thinking inversely compared to what we did last year. So last year we would give you an angle, you would return us XY coordinates. Now we're going to give you XY coordinates and you're going to tell me what the angle is. So we're going to talk a lot more about this. This is just like kind of a bit of an introduction because I need this concept for what's coming after. So the revolutions. I did not write this properly. No, I did. Okay. So if I gave you something like this, I hope this is not going to be too weird, but if I ask you for what angle do we have a sine equal to root 2 over 2? So you had a table last year, which I don't have, unfortunately, but you could go in that table in the sine row and then find where the root 2 over 2 was and then figure out what angle that is. If you did that, you found out that theta was equal to 45. But it's not the only value of theta that works. Because we saw, so that's my first angle. We saw that this point here is not only for an angle of pi over 4, it's also for every factor of 360. So what I'm going to write here, I'm going to say it is true for 45 degree, but it's also true for any other circle. So I'm going to write plus 360 times k, where k is any whole number. We could even subtract if we wanted, right? We could go into negative angles, and that would work as well. It just means that we're rotating clockwise instead of counterclockwise. So that's how we're going to write it this year. Just do take into account the fact that you can go around the circle as many times as you want. Just speaking of that, one thing I want you to notice is there's a second value, and you probably remember that from last year. I do not know what I just did. Okay. From last year, you probably remember that there's actually 2 values. So sine is giving you the y coordinate, right? So I just want to point out the y coordinate's this one here. So it's root 2 over 2. There is another place. So sine, we said, is the y, meaning it's the y-axis. So what we have, oh my goodness, I just can't be up there. It doesn't let me. Okay, so this is my y-axis, which is my sine value of the angle, right? So this value here we just set is root 2 over 2. When I wrote here, sine theta equals root 2 over 2, it means we're looking for every point on this circle that has a y value of root 2 over 2. There happens to be a second value for that. Let's go get it. So along this line here, if it lets me write it, are all values where the y coordinate is root 2 over 2. So there's obviously a second spot on the circle, this spot here, that has an angle of, that has a sine value of root 2 over 2. So we would also need to figure out what that angle is. And if you remember here, it's also this angle with the x-axis is also 45. So it would be 45 plus 45 plus 45, one for this one for this one, and one for this one, meaning this is an angle of 135. So the second angle, for which we have a sine of theta equals root 2 over 2, is going to be 135 plus 360 times k, because again, we could keep going around the circle forever if we wanted to, and we would always get sine of root 2 over 2 every time we stop at that point. I hope that makes sense. I just wanted to introduce you to this here because, like I said, we're going to need it next week. Don't worry too much about solving problems like that where I'm asking for angles, because it's a topic we're going to cover a little bit later on. So it's going to come back. That's the point. That was just a very short introduction, and we're going to dive deeper into this shortly. Let me know if you have any questions. Bye.